Hello and welcome to Explain This, a series where we explain everyday processes using chemistry. I'm your host, Garrett Wade. Previously, we have been explaining the digestive system and how a car runs, but today we will be doing something different. We will be hitting the kitchen to make some mac and cheese, explaining all the way through how or what exactly is going on. So without further ado, let's get started. The ingredients needed to make mac and cheese are very simple, and the ingredients needed in our mac and cheese, Classic Mac, will be no different. We're using the Classic Mac recipe in the mac and cheese cookbook, if you guys would like to follow along at home. Let's start by defining our ingredients needed to create the mac sauce. First, our first ingredient, we have 3 cups of whole milk, which is a homogeneous mixture. This means that the milk has all of its particles evenly distributed throughout. For our second ingredient, we have half a cup of unsalted butter. Butter is a homogeneous mixture made up of about 80% fat, 16% water, and 3% milk solids. For our third ingredient, we'll be using half a cup of all-purpose flour. Flour is also a homogeneous mixture. And for our final ingredient for our mac sauce, we'll be using a teaspoon of table salt. Table salt is commonly known to be a compound due to its proportionate 1-to-1 ratio of the elements sodium and chlorine. Now let's start defining the rest of our ingredients needed for our recipe. We will need 3/4 of a pound of dried elbow pasta and 3 cups of our mac sauce, which we'll be making in a second. We will also be using 2 cups of medium cheddar cheese. All of these ingredients are homogeneous mixtures, including our mac sauce. Now with all of the ingredients out of the way, let's get to putting them all together. Let's start with the mac sauce. We'll first pour the milk into a stainless steel pot. We'll be using stainless steel pots because stainless steel 304 has a very low specific heat at 0.5 joules per gram degree Celsius. This means that it is relatively quick to heat the pot and the ingredients inside up. Stainless steel also has a high melting point at 1535 degrees Celsius, meaning that we don't need to worry about the pot melting on a steel pot. And turning the stove onto medium heat, we start one of the 3 methods of heat transfer, conduction. Conduction occurs when heat energy is transmitted directly through solids. In this scenario, the solids are the stove and the pot. However, it is also important to note that another form of heat transfer, radiation, is occurring as well. Radiation is always happening when thermal energy is being transferred. With the heat on medium, we'll be waiting for 3 to 4 minutes, just enough for the milk to start bubbling. When any liquid begins to bubble after being heated to its boiling point, the bonds in the liquid are breaking and a gas is being released. This phase change is known as vaporization and is a physical reaction, meaning that the milk is not changing its chemical composition, just its form. After this process begins, remove the milk from the heat. Then, in a separate pot, add butter. While still on medium heat, heat the butter until it has completely melted, meaning that the molecules in the butter have weaker bonds and the molecules begin to slide past each other. This process is known as melting, which is when any matter goes from a solid to a liquid. After this physical change, add the flour to the butter and continue to stir with a whisk. Also add the salt. Oh boy. There's our salt. Continue to whisk until the mixture becomes a brown color. Since there's a color change, this means that a chemical change has occurred. After this change has occurred, remove the mixture from heat and slowly start pouring the milk from the other pot. Continue to whisk until the milk, butter, salt, and flour are all evenly mixed. You'll notice that this mixture will get thicker as you keep on stirring, meaning that it has a higher viscosity. Now that we have made our mac sauce, we can begin cooking the pasta. We'll begin by filling a large pot halfway with water. We'll then use conduction from the stove to bring the water to its boiling point of 100 degrees Celsius. Once the boiling process has begun, which if we remember is a physical change, we will then add the pasta. The pasta will be in the pot until a little bit less than al dente. This is actually a chemical change, since the dry pasta that was dry to begin with is now being reintroduced to water, and the water being absorbed is actually changing the chemical composition of the noodles. Leave the pasta in the sink. For now, we're going to mix the mac sauce with our 2 cups of cheddar cheese. So first add the mac sauce, and make sure that all of that is in there. And then add the cheddar cheese. Make sure that you're doing this in a big pot so that we can add our pasta in later. Then, over a medium heat, continue to stir. Once the cheese has melted, which is a phase change and a physical process, add the pasta that was in the sink. Continue to stir. Keep stirring until all the ingredients are evenly mixed. This should be a heterogeneous mixture because the pasta is not evenly spread throughout. Then pour the mixture into a glass pan and put into the oven for 30 minutes at 250 degrees Fahrenheit. While the mac and cheese is in the oven, the final method of heat transfer occurs, convection. Convection is when the heat energy is delivered to the matter through the fluids around it. In the oven, the fluid is the air. Conduction and radiation are also occurring. Finally, you can see that our mac and cheese is done. Due to the smell of the cheese in the air, we can tell that some of the cheese is actually vaporized. Be sure to allow the meal to go through an exothermic process for long enough before serving. We hope that you enjoyed this show, and we'll see you next time on Explain This.